Good morning, dear students. Hope you are doing good. Wherever you are, stay safe. Hope you are all following online classes regularly. Dear students, as we are discussing treatment works, water treatment works, or else different stages in water treatment we are discussing. There is different steps lies in water treatment works. This is about the treatment plant, or else brief view, or else what I can say is partial view of treatment works. And here all these units are constructed side by side after each and every step. After sedimentation, the next step is, after plain sedimentation, next step is sedimentation with coagulation, right? See, all these steps after this coagulation, the next step will be filtration, softening, disinfection, distribution. All are constructed one by one in a sequential order, which is we discuss as a specification to construct treatment plant. Understand? See here, after the treatment, as it is connected to distribution point, after the treatment, water will get much, or else in much pure condition, then it will be allowed to supply to meet the demand of water for various requirements. What are all the different requirements we have seen in the first unit itself? Domestic demand, fire demand, public demand, likewise we were discussed. See, to here or else to this treatment plant, from where we'll get the water? From the intakes. From where the intakes will get the water? Intakes will collect the water from the sources. What are those sources? There are two sources, surface water and groundwater sources. The groundwater may not need the requirement of treatment the way we are discussing now. Of course, it may need requirement of treatment, but it may not need the requirement of treatment the way we are discussing now. Obviously, from the intakes, either like river intakes, lake intake, canal intake, all are constructed or else meant to collect the water from the, or else meant to collect surface water. See, the sources are connected to intake, intakes are connected to treatments, and treatments are, see here, from the treatment, water will be distributed to the public. Understand? See here, now we'll go to the topic what we discuss, or else the followed topic, or else the next topic to the session what we discussed earlier. That is nothing but coagulation with sedimentation. Yes, sedimentation with coagulation. Here we are here. Why it needs coagulation? Because In sedimentation, we may not separate, or else we may not treat the fine colloidal particles. There is no alternate way to overcome the time duration, or else to overcome the problems associated with duration, because the 0.06 mm size particle takes 10 hours to settle in 3-meter depth of sedimentation. Similarly, 0.02 mm, it takes 4 days. That is why we need one alternative method, that is nothing but adding coagulants to trap those fine colloidal particles. By doing so, we can remove those particles more easily. See here, now the coagulant is nothing but is in a chemical, will be added into the water, and it mixes the particles, and it comes out as in a flux form, and that will be treated off from the treatment plants. Before that, how much of coagulant we must add to the water? See, first suppose you are adding salt, maybe in the food, as maybe to the water if you want to drink salt water, or else sugar you are adding. How much of quantity that is needed to make, or else to fulfill the purpose, you must know. Otherwise, the purpose may not fulfill. And similarly, the dosage of coagulant must be known to you, because if you are added less coagulant, the purpose may not fulfill. If you added high amount of coagulant, there also the purpose may not fulfill. That is the reason the coagulants must be added as per the requirements. For that, we must find out the quantity of coagulant that is required to that particular water. How can we find out? That is the question here. Simply by adapting this test, jar test. See, a known sample of water, known sample of coagulant will be added in each of 4 jars. And see here, and these stirrers are allowed to rotate at 30 to 40 RPMs, rotations per minute. As they are connected to electric motor, the pedals will operate, and it will continue up to 20 to 30 minutes. Wherever the best flux formed, that will be the optimum dosage of coagulant. One more time. See, a known amount of water sample coagulant will be added in all the jars. These jars are connected a gear rod with the shaft, and this gear rod is connected to motor, and this gear rod rotates at 30 to 40 RPMs, rotations per minute, and the motor will start and will operate for 20 minutes, 20 to 30 minutes. See here, where after 20 to 30 minutes, in which jar we got the maximum flux, that will be the best dosage, or else optimum dosage to that particular water. Understand the topic? Known sample of water has been taken in all the jars. The coagulant is added at different quantity in all the jars. The coagulant is added to different quantities in all the jars. At which quantity we got good flux will be treated as the optimum dosage. Understand? Different quantities of coagulant will be added in different jars to the known amount of water. The water sample is, the quantity of water sample is same, but the quantity of coagulant is differ at each jar. Wherever we got the best floc, that quantity is the optimum dosage of coagulant. And how it is adjusted? 30 to 40 rotations per minute. How much time the motor will operate? 20 to 30 minutes. After 30 minutes, in which jar we got, wherever we got the good flux, that particular added quantity will be the optimum dosage of coagulant. Next is fluctuation. See, that much of coagulant will be added, the quantity of what coagulant will be added to the water, and it will start skimming or else mixing, which is called as flocculation. See, after the finding of optimum dosage, the coagulants will be mixed with the water for flocculation. Flocculation in the sense foam formation, foam on the top of the, or as on the surface of the water, which can be explained with the help of the diagram. See here, this is a flocculator to the inlet, that means from the sedimentation tank. By adding the coagulant, it enters into the flocculator, and this is the, I mean, what I can say is stirrer, and fixed on the bearing, and it stirs the water 2 to 3 rpms for forming or else to form the flux. Likewise, after a period of time, the flux will be formed on the surface of the water body. The flux will be removed by mechanical shafts, and the water will be sent to the outlet. What is the flux here? The fine colloidal particles which are unable to settle will mix with the flux, or else the foam that will be taken off. See, the weighted particles are settled on the bottom, and unable to settle particles are mixed with the flux and reach to the top of the surface, or else reach to the top of the water, and they will be taken off from the water by using mechanical scrapers. Understand? This is about the flocculation. Next one is example of coagulants. See here, aluminum sulfate is the best example of coagulant to be used in. I have given only one example so that you can easily understand, easily remember. Used in sedimentation process, it is called as alum. It is available in dirty gray color as in a lumps, which has the 17% of aluminum sulfate. When it is added in the water, the aluminum sulfates reacts with the impurities and comes out as a flux that will be taken off, and here the water will be sent to the next category, or as next outlet, or as next unit. Understand? So here sedimentation with coagulation. Why we are discussing? Because the fine colloidal particles may not settle on the bottom. That is the reason we should go for any alternative method, that is nothing but adding of coagulants. How we are adding coagulants? The quantity, how we can define, how can we achieve, how can we know that amount of coagulant that has to be added to the water? Simply through jar test, where different quantities of coagulants will be added in different jars to the known sample or known amount of water sample. Wherever we got the flux, because of the rotations of this shaft, which is fixed to 30 to 40 rotations per minute, and the same will be operated 20 to 30 minutes. After 30 minutes, the flux wherever we got considerable amount, that is good flux, that will be the optimum dosage of coagulant, and the same will be added into the water, and the process will start. After adding coagulant, water enters through the inlet into the fluctuator, where the rotating shafts are fixed to a bearing. See here, by doing so, as the stirrer steers the water with a rate of 2 to 3 RPMs, rotations per minute, all the fine colloidal particles comes and settles on the top of the water here. From here, the flux will be taken off, or as the flow, a foam which has the fine colloidal particles will taken off from the surface by mechanical scrapers, and the water, by crossing all these units through the outlet, will be sent to the next stage of treatment. Understand? This is about the sedimentation with coagulants, or else coagulation. See, sedimentation with coagulation. This is the next step that lies in flowchart of treatment. Am I right? Have a look over here. Flowchart. See, from intake work, including pump system, water enters into the treatment plants. Firstly, the water underwent the process of plain sedimentation. We have seen different techniques and different tanks in plain sedimentation. Now the water enters into the next stage, that is sedimentation with coagulation. Understand? See here, after sedimentation with coagulation, the next step is filtration. Understand? The next step is filtration. How we can filter the water, that we will discuss now. See here, filtration. In the sedimentation process, before that, what is the need of filtration we'll discuss now. In the sedimentation process, all the weighted particles settle and will just taken off. In the next step, the fine colloidal particles also removed by adding coagulants. Of course, we were removed the weighted particles as well as fine colloidal particles. It doesn't mean that water is in pure condition. Still, there are certain impurities in the name of bacteria, algae, and other fine particles. They also has to be, or as they also must remove from the water before we are sending, or before we are supplying the water to the public. Understand? How we can remove this bacteria, algae, any other leftover fine particles from the water, we will discuss. Understand? How can we discuss? See here, the process, how we can remove in the name of filtration. That is why I mentioned there the process of filtration, where bacteria, color, odor, taste, and other impurities like excess iron, manganese, and other any impurities will be removed in this filtration process. Understand what is the filtration here? Because the removal of bacteria, algae, and unnecessary, chemicals, unnecessary additives like manganese, iron, when they are excessive, when they are crossed permissible levels, they also has to be, they must remove from the water, and all these can be removed through the process by name filtration. We'll see what is happening in this filtration, or else what are the different stages that we may observe in this filtration. That is, there are different mechanisms that will take place in this filtration. First one is mechanical stirring, sedimentation, bacteriological action, electrolytic action. All these mechanism will take place in filtration. Why we need filtration? To remove the bacteria, algae, odor. I mean, order in the sense of bad odor, even the extra elements when they cross the permissible levels, like iron, manganese must be removed, or else any other impurities or any other toxic materials also must be removed. See, iron and manganese is required elements in water, but when they cross the permissible levels, they must be removed. Understand? That is why filtration is needed. Now, what is the exact mechanism that holds in filtration? We'll discuss in next class. If you have any doubts, please contact me in the domain, whatever you feel convenient, either phone, message, or mail. Thank you.